Welcome to recording 1C in our series on factoring quadratic equations for Unit 4, Chapter 4 of Mathematics 2200. We'll be looking at how we can solve quadratic equations by using our factoring skills. The zero product property, we have to look at that first. It says if you multiply two numbers and the answer is 0, then one of those two numbers you multiplied had to be 0. How does that apply in an expression such as x outside of x minus 1 equals 0? What values of x would result in giving us 0 for this expression? Well, if I said that x is 0, then I would have 0 times 0 minus 1, and that's 0 times negative 1 equals 0. So that would give us 0 equals 0. On the other hand, if I want this bracket to work out to be 0, what number subtract 1 would we use there to get 0? Well, it turns out that if x is equal to 1, that bracket would work out to be 0. And let's see what happens here. We would have 1 outside of the brackets, but we would have 1 minus 1 inside the brackets. So we'd have 1 times 0 is 0, so 0 equals 0. Let's simplify the process a little bit here. For the next one, we got x plus 2 times x minus 1. Well, we already know for this second bracket from the first example, if x was equal to 1, that bracket would work out to be 0. On the other hand, if this bracket worked out to be 0, then we would also get 0 for the whole expression. So we would use negative 2. What number plus 2 gives us 0? Well, it's negative 2. So really, if we have the factored form of a quadratic equation that's equal to 0, we can simply make each factor equal to 0 and determine the values of x that would result in a multiplication that would give 0. Let's go to example 1 here, solving a quadratic equation by factoring. We are asked to find the roots of the quadratic equation x squared plus 26x plus 25. First thing we have to do is write the equation in the form ax squared plus bx plus c equals 0, which it already is in this case. The next step is to factor the left side. So we have as our factors x plus 25, x plus 1. If you're not sure how I factored that, you should review recording 1A. We next apply the zero product principle by setting each factor equal to 0. So we have x plus 25 equals 0 and x plus 1 equals 0. And we solve for the variable. In this case, x equals negative 25, x equals negative 1. We should check our answers in the original equation just to make sure they're correct. And it looks like the negative 1 works, and let's try the negative 25. And it looks like the negative 25 also works as well. On to example 2, finding the zeros of a quadratic function by factoring. Recall that the zeros of a function are the same as the roots of the corresponding equation. In recording 1A from our recordings in Section 4.1 on roots and x-intercepts, etc., we found the x-intercepts of this function, and we had to do it by constructing an accurate graph and determining where the graph crosses over the x-axis. That's not always really easy to do. Let's do this problem now by factoring. So we write the corresponding equation, replacing y with 0. So we now have 2x squared plus 2x minus 12 equals 0, and we need to factor it. In this case, I have a common factor first. So I'll take that out. 2 outside of x squared plus x minus 6 equals 0. Then the factors of x squared plus x minus 6 are x plus 3, x minus 2. Now the only factors we have to worry about for using our zero product principle are these two. There's no way 2 without another variable that could ever work out to be 0. So we'll just say x plus 3 equals 0, or x minus 2 equals 0. Therefore, x equals negative 3, or x equals 2. Compare that to the x-intercepts at negative 3 and 2. There should be agreement there. So if you had a bit of graphing technology, you could always check your work against a graph of the function as well. For our final example, there's a step here now that we have to do that wasn't in our first two, and that is rewrite in the form ax squared plus bx plus c equals 0. Always make sure it's equal to 0 first for a quadratic equation before you try to factor. So that will give us 3x squared plus 14x minus 5 equals 0. Once we have that, we then factor, and we have 3x and x at the beginnings, and it looks like we'll have to have a 5 and a minus 1 here at the ends. That will give us the correct factorization, and that's still equal to 0. So we make each factor equal 0. 3x minus 1 equals 0, or x plus 5 has to equal 0. That second one is a little easier to rearrange. We got x equals negative 5. But in the case of the first one, 3 times what subtract 1 is going to give me 0. That's not always as easy to see. It's a third, but we will rearrange it to get that answer. 3x equals 1, and we divide both sides by 3 to get x equals 1/3. Try getting an answer like that from graphing. Very, very difficult. Factoring is more precise. So the zero product principle is if a times b equals 0, then either a equals 0 or b equals 0, and can be used to solve a quadratic equation. To solve a quadratic equation by factoring, write it in this form first. Factor, apply the zero product principle by setting each factor equal to 0, then solve for the variable. And of course, you should always check your answer in the original equation, which I didn't do in the last two examples. I left it to you.